Hey everyone, welcome back to our Python programming series. Today we are diving into two essential Python concepts that often come up in advanced coding: generators and decorators. I am Bokkor Shiddik, studying statistics at Mubasshirah University, Rampur, and I will be covering generators.
I'm Mubasshirah Tamanna. I'm studying data science at United International University. I will be covering decorators. Together, we will break down what these tools are, why they are useful, and how to implement them in real-world scenarios. So, let's get started.
Let's start with generator. First up, what exactly are generators? Generators are a type of iterable like list or tuple, but instead of holding every item in memory, they generate each item on the fly. You don't need all the item loaded at once. Generators create it only when needed. This can save tons of memory, especially with a huge dataset. So now, how do we create a generator in Python? Let's start with a simple example. Here's the function we define my generator that uses the yield keyword instead of return when they call. So my generator, it doesn't run the code immediately. So let's run it and see. And you are seeing here, it doesn't run the code immediately. Instead, it returns a generator object. And each time we ask for the next item, it yields or produce one value at a time. So let's see how to actually use this generator. Here, notice that we use the next function to get each item for the generator. Every time we call next, the generator moves the next yield statement. So let's run it. And you're seeing here 1, 2, and 3 is the output. Okay, why should you care about generators? Imagine you want to generate a million numbers. Instead of storing them in a list, which would use up a lot of memory, you can use a generator. For example, this is a code define count up to max. N is equal to 1, while n is equal to max yield n plus is equal to 1, and generator is equal to count up to dash. So now let's run it, and you're seeing here there's 1 and 2. With this, we don't have to load a million items to memory at once. Instead, we just generate one numbers at a time when needed. Generators also have a compact syntax called generator expression. They look like list comprehension, but with parentheses instead of square bracket. For example, this is generator expression x into x for ix in range 10, and then print generator expression, and then this generator expression squares each number in the range 0 to 9. It's like a list comprehension, but way more memory efficient. So let's run it, and you're seeing here 0 and 1, and you're seeing here we also use another two next generator expression, and for that the result is 4, 9. And if we also use another generator expression for the print, and we will use 16, that means this is for 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16. And if we use another generator expression for the print function, then it will be 25. Okay, that covers the basic of generators. Now let it over to Mubasshirah Tamanna from United International University to explain decorators.
Now, let's talk about decorators. Decorators are very useful in many Python applications, especially for adding reusable functionalities. First of all, we have to know what is decorator. A decorator is a callable that takes another function as an argument. It has the power to replace the decorator function with a different one. Here is an example. The decorator function is defined to accept another function func as a parameter. This is what makes it a decorator. Inside decorator, we define a wrapper function which will act as the modified version of func. In wrapper, we add print statements before and after calling func. This allows us to add extra behavior around the original function. Returning wrapper. The line return wrapper returns the wrapper function from decorator. When decorator target is called, wrapper is returned and assigned to target, effectively replacing target with the decorated version of itself. Finally, when target is called, it runs the wrapper function, which includes the additional print statements along with calling the original target function in the middle. When I run this code, the output will be here. The decorator function acts as a wrapper for func, letting us add code to run before and after func executes. Here, return wrapper is the key step in decorating a function. Returning wrapper lets us replace the original function with this new decorated version. To apply the decorator, we need to call decorator target and assign the result back to target. Here, we call decorator with target as its argument. Since decorator returns wrapper, this effectively replaces target with wrapper. This step ensures that calling target will now run wrapper instead, which includes the extra functionality. We can also use this method. Then we don't have to use this line. @decorator means we are using decorator. Here is another example. We have to create a decorator that checks the date and time to control the execution of a function. For instance, we could design a decorator that only allows a function to run on weekdays during the business hours 9 a.m. to 5 p.m. Here, we can check the current day is a weekday or not. Then test the decorated function. If it is a weekday and during business hours, it calls function. Otherwise, it prints a message indicating that the function can only run during business hours. By using only during business hours above perform task, we apply this time-based restriction to perform task. If it called between 9 a.m. and 5 p.m. on a weekday, it will print that this function will only runs during business hours. Here, this example shows how you can use decorators with date time to control the execution of a function based on a specific date and time conditions.
So today we explored two powerful Python tools, generator and decorators. Generators helps us handle large sequence and make our code memory efficient.
And decorators let us add extra functionality to functions in a clean and reusable way.
Thanks for watching. See you next. Bye bye.